Hi, everyone. Thank you for the invite to the Q2B organizers. We're very happy to be here. As we were introduced, me and my colleague Portia here are acting today in our capacity as MBA students.
Don't know what happened with the tech.
The Frankfurt School of Finance and Management. So really happy to be here today, and thanks for your attention during our talk. So we'll speak today with the title of our talk being Exploring the Business Value of Quantum Computing for Companies within the QUTAC. I'll explain who the QUTAC is in a moment. And specifically, we explore the technical and financial considerations based on the current thinking within the companies that are part of this consortia. So this is your consulting team. We actually worked with this consortia and framed the project as a consulting type project. And the project was co-led by myself and Portia, coordinating with the rest of the stakeholders that are part of the consortia. And this is what we set out to do. So we understand that quantum computing is still in a very early stage in its maturity, which means there aren't many practical applications for businesses and firms as yet. We also know that there are several technical limitations, such as limitations on complexity, ability to scale, accessing the hardware, and also things like talent within this field. But we also know that there are methods rapidly being developed to mitigate some of these limitations, which results in the business data scientists trying to find ways to capitalize on this rapid developments in the field. So the problem, as we framed it here, is technical implications are not easy to articulate, and financial implications in particular are not easy to quantify at this point, given the maturity of the technology. So this is how we scoped out our consulting project, and we limited to evaluating just these two components. One thing I'll mention is, because this was tried to fit into an MBA thesis, we didn't have so much time, so we had only about 4 to 5 months in order to develop the project, work together with the consortia, and distill the insights. And we're happy to share this with you here today. Going to the next slide, this is eventually what we ended up concluding and recommending, and the following slides will go into details about how we reached to these recommendations. So when it comes to the first aspect of our project, the problem formulation, we ended up recommending the companies that are part of QUTAC to leverage existing requirements elicitations framework, and I'll speak more about what that means. And in particular, we found 2 consulting frameworks from McKinsey and Accenture who proposed very specific quantum computing problem formulation frameworks. They account for some unique aspects of quantum computing beyond those that other frameworks are looking at in problem formulation more broadly. We also recommended here to explore the Quantum Zoo database as quite a comprehensive, publicly available catalog of available quantum algorithms. We weren't sure that folks were so aware of this database. And then on the other side, on the project valuation, we understood that financial value is only envisioned in a future quantum-ready state, and the primary driver of value right now is non-financial value. And we proposed also some frameworks to articulate the non-financial aspects, particularly the entering a new market framework and the PVI framework, the Project Value Improvement Framework, which have some robust mechanisms to account for non-financial value, which are very important for companies as they start making their first steps into quantum computing. Okay. So I'll go quickly into some introduction on how we even got to our consulting question. So in the consortia, we identified 2 users or 2 participants of the consortia to act as our primary customer or clients. And they basically came to us saying it's very difficult for companies to identify use cases, and it's also very difficult for companies to identify what use cases are going to be economically viable, economically successful at all or in principle. We also know that the initial first problems of economic relevance that can be solved with quantum computing is difficult to articulate, and it's also difficult to understand when any potential economic value might result from these initial use cases. So we took our engagements with these 2 primary customers, and we formulated some consulting questions. So we understood that our clients were eager to find out what types of problems can be solved or are viable or amenable for any quantum computing solution, And then secondly, which of those have some sort of economic value, and most of this being non-financial value. We investigated then this in more detail, how possible use cases are developed, so the problem formulation piece, and then how are they screened for value based on the collective experience of the members of this consortia. And then the outcome for our project was to define an appropriate business process framework, both for selecting the viable projects as well as for articulating and thinking through their economic benefits. So here I'll talk very briefly, with some introduction, who's the QUTAC. I already mentioned the client problem. And I'll briefly talk about the market environment before diving into the findings of our study. So the QUTAC is a consortia of 13 German companies. They're large German companies spanning various different industries, so all the way from automotive to manufacturing, chemical, pharmaceutical companies, as well as companies involved in finance and insurance and the technology industry. The QUTAC is a consortia with the common aim of raising quantum computing to the level of large-scale industrialization or industrial application. And the intention or the objective to make quantum computing commercially available and economically successful, particularly in Germany as a country and the wider European region. I also want to go through a couple of quick points on the market environment. So I already mentioned, quantum computing, as is widely known, is at a very early stage of maturity. There aren't many practical applications for businesses and firms today, and there are currently various technical limitations that are rapidly being mitigated. We found that when we did a market landscape analysis, that the most common problem domain was that of quantum optimization. And in the public domain, and so in literature and white papers, we found that about 50% of use cases are currently in the optimization space, with simulation, machine learning, and to a smaller extent, cryptography. We found that finance, materials, and high-tech industries are currently playing the largest role in identifying and exploring use cases globally. For the purposes of this study, we also wanted to define what we call a use case. So in this context, it's described as a potential use of quantum computing that has some form of business utility. That includes the quantum computing as well as quantum information sciences. And then a note on the hype. So we also looked at how does quantum computing fit into the hype cycle? This is a commonly shown chart of the Gartner hype cycle, and as a mechanism to help companies understand when a new technology begins to get popular, when it reaches its hype of expectation, and also when there is a loss of interest or it results in this trough of disillusionment. It also helps businesses to make some decisions on when to invest in technologies such as quantum computing, given the maturity journey. And we also were able to compare quantum computing to other similarly comparable technologies, and similarly only in terms of its uncertainties around the technologies as well as the risk behind the technologies. We compared it to AI as a high-risk, high-uncertain technological development, as well as basically an industry domain, so pharmaceutical R&D, where there is a lot of risk behind molecules being identified in the lab and then eventually reach commercialization. So we try to see what are the mechanisms, what are the thoughts around handling the uncertainties and the risk by comparing it to these other two domains. There's a lot of things that we found, but one key message I want to leave here today is we found that both through a comparison of AI, particularly productive AI, things like chatbots, which are widely used by many companies at the moment, and when we compare it to pharmaceutical R&D, the key finding, one of the key findings that we made was the primary driver. There are many, but one of the primary drivers that were able to carry a technology past this trough of disillusionment and towards a productive state was the underlining that there is some form of commercial value, initially being non-financial and then eventually translating into something financial. We just want to make this point because it is important, even though it is quite unclear what the financial value of any quantum computing use case is right now, for companies to actually think about this and having some kind of structure to think through this is already showing to be quite helpful, at least for the companies within the QUTAC. Then diving very quickly into the problem formulation literature. There's a lot here, I won't go through it, but I want to just mention 2 points. The 2 frameworks that we proposed were the 2 consulting frameworks coming from McKinsey and Accenture. And we know there's no perfect framework, we also know there's rapid developments in the field, but we found that using these 2 frameworks to help companies think in a structured way through what use cases might be amenable for a quantum computing solution, and also thinking about limitations and what is possible today, hardware limitations, availability and ability to match algorithms that are publicly available are all challenges that are out there. And also frameworks like this help then put things into context and give that structure to allow folks to think through this in more detail and in a structured way. Similarly, when it comes to project valuation, this was quite an interesting topic because there are several perspectives of value. So there are internal customers. So firms, internal customers are the internal business units where they are actually using these use cases to support functions basically inside companies. To do things better in-house, as it's on the slide. And then external customers, which are kind of the revenue-generating counterpart, who then pay directly for product or services that's coming out of a company. We also find that there's different perspectives of value. They can be monetary value, which is most commonly known, but also psychological value, social value, functional value, which is also being considered by companies as they think about these initial use cases. We also know, it was mentioned many times today and yesterday, that one potential quantum return is potentially a speed advantage for some algorithms, and there's also the potential ability for quantum computing to address problems that are thought of as classically intractable. Just to highlight here that the 2 recommendations that we made was the entering a new market framework and the PVI framework. There are limitations here as well, but there are also some robust mechanisms to account for these non-financial value, like the social, psychological value, and any kind of speed advantage or performance advantage that comes from a quantum solution. So in getting to our recommendation, we followed this 7-step problem formulation approach, where we took the client problem, defined the problem, did our analysis and decided our findings, and got to our recommendation. We took here both a evidence-based approach by firstly going to literature to see what was out there, and we supplemented that with the experience-based approach from these 13 companies that are part of the QUTAC. So we had a series of interviews that we structured based on the findings of our literature analysis, and we present here the findings in terms of the qualitative findings from the interviews, supplemented with more quantitative findings when we verified these interviews in a type of scoring panel discussion that we'll talk in the next couple of slides. And we also found that this was quite efficient in getting all the results that we need in a very short period of time. Right, Portia? Do you want to jump in on the thematic analysis topic?
Absolutely. Thank you. So what we found here is initially we did interviews, and in the first round of interviews, we asked, so tell us about your quantum computing project. What are you doing? What are the products? What is your requirements elicitation process? And it looked like we were thinking so many steps ahead. We had to backtrack when we were told, look, quantum is still in its early stages. We also are working on R&D activities. So going into the interviews, we had to start reintroducing the topic to say, we do understand that quantum is in its infancy. However, in the projects that you're working in, what is it that you do? How do you do requirements elicitation? And how do you define value? Is it financial? Is it non-financial? And for those that invest in your projects, what are their returns? So in doing those interviews, we sort of, in hindsight, applied the theory of planned behavior. And it's something that we thought to mention, although it's more philosophical and maybe in the human sciences, we thought it's nice to recognize when it's actually unfolding in reality. So in the analytics of the data, we collected our first round of data in interviews, and we did a thematic analysis. And in the deep diving of the analysis and results, this is what we found. We had 10 companies interviewed out of 13, and we thought that was a good turnout. We had 19 interviewees in total, and roughly 40% of them were in management or leadership, and 60% were more technical representatives. And through the discussions and interviews, we stopped when we reached data saturation, and we started hearing common themes. We started hearing basically the same answers from different companies in various industries. And we understood that the challenges are the same, and also most companies are moving at the same pace in this area. And with regards to the two aspects of project management in quantum computing, we looked at problem formulation and project valuation. So we drilled down to three main emergent themes from the data that we identified. In problem formulation, we noticed that the problems that are being formulated are based on a futuristic view of a potential solution for something great if and when the quantum computer can perform better, or if and when the bigger quantum computer becomes available, this is the type of solution we will have available. So it's not currently implementable and commercializable. It's looking for a future-ready state, as Omesan has said. And most of the activities happen to be exploratory or experimental in nature, in the form of research and development activities. And in terms of project valuation, one of the emerging themes that we reached saturation, I think, by the third or fourth interview, where we constantly heard about the value ecosystem of quantum computing. And also there was concerns about risk, and in noticing that this is an emerging technology, like most emerging technologies, it's risky to get into. Then further in the discussions, we understood that research and development activities also include collaborations to sort of absorb this risk, and also risk was seen as an opportunity. And some of the main findings for the specific themes is that we noticed that the internal customers were the majority of who the products and services in the research and development were catered for. And customers are not looking for quantum-driven technology. They were looking for solutions. And the teams that are working in quantum computing either approach internal business units or recommend to already existing clients that for this product that we already have, we can fast track it or optimize it using quantum computing. Are you interested? And can we go ahead with it? And the process is not yet structured or formalized. And the main problem scopes that they looked at are simulations, optimizations, and machine learning. Encryption was not so much identified in our discussions. And the main themes, I think I've touched on them. I'm not going to go into detail, but it was problem formulation, saying currently there are capabilities of quantum computing that we have just explored. We don't know how much of capabilities this technology offers. We don't know how much we can do with it. And identifying the right problems to explore is on its own a challenge for a lot of companies, not knowing what it is that we are looking to solve with this technology and how much of our problems this technology can solve. And therefore, it brings about the need to explore and do research and development. But in doing research and development, stakeholders want some return. Next slide. And this return can only be promised in that futuristic commercial state. And Omesan, what do you think about the futuristic value that is proposed?
Yeah. So I'll talk here about the value. I already mentioned the different perspectives, external value, internal value, and then value for the firm itself, the company as a whole. What we found was we also interpreted the data through the business value chain framework. And what we found that external customers are, as Portia said, not interested in a quantum-assisted technology. They just want better products and services. So what we found that the external customer perspective is interested in the end result of primary activities. And the primary activities is everything that a business does to make and sell its products. And the internal customer and the enterprise value itself is currently viewing value in terms of strengthening and supporting their support activities in order to make companies more primed and ready for any future quantum-ready state. So I think that summarizes a lot of what we heard of in terms of value, in terms of non-financial value coming from the companies. We also saw this future-ready state I already mentioned, is priming these companies to capitalize when the technology becomes more mature. And what you see on the left-hand side, the little quantitative chart, is the sentiment was echoed quite strongly across all the companies within the QUTAC. One point I'll just mention is on the marketing and position value. We dive deeper into what does that actually mean. And in terms of marketing and positioning, companies are actually thinking about these initial use cases as a way to stimulate some digital thinking, particularly in some German companies who are very set in their ways, they're very old, and they have some inertia in adopting digital thinking within the companies. So companies are using quantum computing as a way to stimulate this, using the hype, using the excitement to trigger some form of behavioral cultural change. They're also using their first steps into quantum to position themselves as being a prime partner to partner with other companies, to partner with tech companies, academia, and also as a way to maybe attract talent to come into some of these companies. Just to wrap up with some of the risks and opportunities that we found. So it's clear that there is lack of knowledge, lack of know-how. There is uncertain opportunity cost integrating into business workflows. There's clearly an expectation misalignment a lot of the time, driven a lot by hype in the field. There's also some ambiguity, some uncertainty around IP ownership as well as technology transfer, particularly when working with many companies and academia hand in hand. And there's a lot of challenges in trying to iron this out. I'll speak about that as a next step as well. In terms of opportunities, there's clearly some transferred benefits to the classical field, and as well as a lot of opportunity for open collaboration. This just echoes the quantitative result that we found. Portia, do you want to wrap us up with the conclusions?
Yes, in conclusion, most of the interviewees highlighted and given a consensus that they see commercialization in the next 5 to 10 years. And we actually recommend that a lot of companies should join in terms of exploring quantum computing and become trailblazers in their own niche areas, and also explore the quantum zoo as a database to use. And in terms of frameworks, we recommend that companies use the currently available valuation frameworks, as well as requirements elicitation frameworks, and integrate those into their projects rather than trying to build their own. I think with that, we'll take some questions. Thank you.